You know, it's funny how some things in life change in a really, really predictable way. I mean, from a savings account balance to the seats in a movie theater, there's often this hidden pattern just sitting there. Well, today, we're going to pull back the curtain and unlock the secret language of these patterns.
Okay, let's just dive right in with a question. What on earth could a business truck that's losing value every year possibly have in common with a kid's weekly allowance that keeps going up? Sounds totally random, right? But believe it or not, the answer is the key to this whole thing.
All right, let's take a look at our first case study. A small business buys a brand new truck. Now, for tax reasons, its value goes down each year. That's called depreciation. And this, right here, is a perfect real-world example of one of these hidden patterns.
So let's look at the numbers. In year one, the truck's worth $21,600. By year two, it's dropped to $18,200. Then $14,800 in year three, and so on. Just looking at these values, can you kind of feel the rhythm? Can you spot the rule? What's happening every single year?
So, if you were thinking, hey, I see something going on here, you are absolutely right. There is a consistent mathematical rule hiding here in plain sight. Let's crack this code together. To find the rule, all we have to do is subtract each year's value from the one before it. So if we take year two's value and subtract year one's, boom, negative 3,400. Okay, what about the next pair? Years 3 and 2? Same thing. It's the exact same number. And again, for years 4 and 3, it's constant. This number, this negative $3,400, that is the secret key. And in the world of math, it's got a special name, the common difference. It's the fixed amount that the sequence changes by every single time. And that, my friends, leads us right to the official definition. Anytime you have a list of numbers that changes by the exact same amount each time, just like our truck's value dropped by $3,400 every year, it's called an arithmetic sequence, and we call that fixed amount the common difference, usually labeling it with the letter D. Okay, let's make this super clear. Check out these two lists. On the left, we go from -3 to 1. That's adding 4. Then from 1 to 5, that's adding 4 again. The difference is constant. So yes, it's an arithmetic sequence. But look at the one on the right. First you add 1, then you add 2, then you add 4. The difference keeps changing. So nope, that is not an arithmetic sequence. Okay, so we can spot these things and figure out the next step. But what if we want to find a step way, way into the future? I mean, that could take forever, right? We need a shortcut. We need a much more powerful tool. Think about our truck again. Finding its value in year 5 is easy enough. But what about in year 20? Are we seriously going to sit here and subtract $3,400 19 separate times? No way! There's got to be a better way. And guess what? There is. So how do we build this ultimate shortcut? Well, let's just look at the pattern. To get to the second term, we add the common difference once. To get to the third term, we add it twice. For the fourth term, we add it 3 times. Do you see the relationship? To find any term, n, we just take the first term and add the common difference, n minus 1 times. And that right there, that gives us this beautiful, powerful tool, the explicit formula. With this little equation, we can jump to any term in an arithmetic sequence instantly. All we need to know is where it started and what that common difference is. All right, time to put this new formula to work. Remember that kid's allowance from the beginning of our chat? Let's solve it. So here's the setup. A 5-year-old gets $1 a week. Every year on his birthday, his parents increase that weekly amount by $2. That constant $2, that should be a huge light bulb moment for you. We are definitely dealing with an arithmetic sequence here. So here's the specific question we need to answer. And now, instead of listing out every single year's allowance one by one, we can use our formula to jump straight to the answer. To use the formula, we just gotta plug in the right numbers. So let's identify our pieces. The first term, a sub 1, that's the starting allowance, $1. Easy. The common difference, D, is that annual increase, $2. And since he starts at age 5 and we want to know about age 16, that's a total of 11 years of increases. So we just need to put it all together. We start with our initial dollar, then we add our common difference, the $2, multiplied by the 11 years of increases. And when you do the math, what do you get? Boom! $23. That's his weekly allowance when he's 16 years old. See? No need to count it all out on your fingers. The formula just gives you the answer. Now, that explicit formula is fantastic for jumping way ahead. But there is another way to think about these patterns, a more, let's call it, a step-by-step approach. So you've got two flavors here. The explicit formula on the left is like a time machine. It takes you to any point you want instantly. The recursive formula on the right is more like taking it one step at a time. It simply tells you how to get to the very next term from wherever you are right now. All right, so let's boil all this down. What are the big things to remember? First, arithmetic sequences are all about that one simple thing, a constant change, that common difference. Second, if you were to graph one, you'd get a perfectly straight line. That's the constant change in action. And finally, the explicit formula is your secret weapon. It lets you predict any term, any time. So, you have the formula now, you have the key. It's a really powerful way to see the future of any pattern that grows or shrinks at a steady rate. So my question to you is, what patterns out there in your world are you going to start predicting?